slides. First of all, before describing the case, I would like to make a short introduction of on stem cells, especially for youngest surgeons. So stem cells, when they divide, they produce another stem cell, but which is what is most important is that they produce post-mitotic transitional cells that glide or slide along the corneal surface, and then they get to the apoptotic cells, and so they renew them. So, but we must know that there are different kind of stem cells. We have the embryonal, embryonal ones, the totipotent cells that may produce any other kind of cells, and which are taken from human embryos of about 5 days of life. And then we have the embryonic germs, pluripotent, that can only give rise to certain types of cells, and they are harvested from embryos of about 6 weeks of age. And then we have those from the umbilical cord and the placenta, which are pluripotent as well. And then we have the adult cells taken from the bone marrow. And then the ones we're most interested into, which are limbo corneal stem cells, which are unipotent. They can only give rise to a specific type of cell in the cornea. So they are localized in the basal membrane, so in the bottom layers of the limbus. They multiply themselves and they glide along the corneal surface as a transitional amplified cells, ATC, and then the ones that desquamate into the tear film. When we have a normal condition, under normal conditions, we have especially dormant stem cells which are reproduced very slowly. They produce another stem cell. They give rise to an amplified transition cell, and then we have the differentiated terminal cells. And then, but if a stimulus is provided, we activate all stem cells, and so we have a very big amount of cells of ATCs, as well as terminal cells, which are the ones that have to make up for the corneal damage. And there are three different processes underway here. So how the healing process or the gliding process takes place. So we have the migration, the proliferation, and the addition stage. And of course, I am accelerating because we are running late. But however, this is schematic of the fact that the damage happens always from the periphery towards the center and not the other way around. This is because if we have well working stem cells, we may have the corneal lesion be closed, and therefore the conjunctiva and its vascularization gets into the cornea, and this and so we may prevent the defect of the transparency of the cornea. So here, the previous speaker has mentioned this, so limbal deficits, congenital diseases, autoimmune diseases, traumas, and iatrogenic forms. Okay, even faster here, so I can make up for some delay. And then we have dysplasia, for instance, in 90% of cases we have an absolute limbo deficiency, and Stevens-Johnson syndrome and pemphigoid are very well known. Unfortunately, these are very severe cases related to limbal deficiency and eye dryness. So this brings about a continuous laceration of the cornea, so the whole corneal surface gets desquamated. And then we have the pemphigoid, which is a disease that sometimes is not readily diagnosed and identified, which instead in time may lead to the total loss of the whole ocular surface. And then we may have a chemical or thermal damage. And here we have instead a iatrogenic damage caused by multiple diseases, but especially two perforating procedures, which, as we know, today has been virtually eliminated or nearly so. But what can we do? We do have stimulation techniques, so we can stimulate the amniotic membrane, trying to reduce the inflammatory processes, which are particularly severe. And then we can simulate possibly existing limbal stem cells and re-establish the corneal epithelium. Or we may also replace the by means of conjunctival limbal autograft. And here we need a sibling or a relative having exactly the same features for an allograft, or we can have a conjunctival limbal allograft from cadaver, and finally we can resort to cell cultures. There are benefits and disadvantages to each of these techniques. Of course, the best one is the CLAU, conjunctival limbal autograft, because we may harvest stem cells from the fellow eye, so we do not have to use immunosuppressants, and even with a sibling or relative CLAL, we do not need immunosuppressive treatment, whereas it is necessary throughout the life of performing immunosuppressive treatment in the case of cadaveric keratolimbal allograft, or the cells cultures are probably the next generation of cells. So for the time being, this is quite an expensive procedure. Here we may see a case. Immediately we have applied a magnetic membrane to try and reduce as much as possible the fibrosis that implies the damage of all stem cells. And so when we think of an allograft, the goal is not to use any sutures because we must eliminate the inflammation, and so fibrin glue for the grafts, and especially we should use corneal beds with a twofold purpose. First of all, we want to mobilize the bed the flap that or the graft that we implant in a damaged eye. But then we may use a ionic material lens, so a lac. So I'm not talking about silicon hydrogen, but it should be ionic because the surface should allow for the attraction of the eye drops or the medication we instill into the fornix, and therefore allow for a superficial distribution of the drug. So this is the simplest technique. This is the fellow eye, the fellow healthy eye. So no special anesthesia is necessary here. A subconjunctival anesthesia is enough because we need to harvest part of the conjunctiva. Because, as I was saying before, the stem cells is not only to be found within the limbus, but we should also harvest the ones which are placed at the conjunctiva. Needless to get into the anterior chamber, a very small flap or harvest of 1 millimeter is necessary because we need to use and to harvest already amplified cells, so cells that have already transformed, so to have a better traction. So as you may see, this technique is extremely simple and it allows a very easy harvesting. This is the damaged eye. You may see that the inflammatory process with the amniotic membrane and by means of contact lenses has been significantly reduced. We have removed a part or the whole of the fibrovascular tissue. Okay, let's move on. You have to remove the necrotic tissue, the perilimbar necrotic tissue, because this is very negative when in terms of for the repair process. And so the graft, this is the staining, which may be handy or useful in order to identify the correct positioning. And then with the fibrin glue, with the two components, the component A and B separately, so as to have the time necessary to unfold it properly. And then finally, we fit the contact lens without any suture. And so we leave the altered conjunctiva free. And I apologize for, how to say, speaking a bit